feel like not necessarily having time to kind of get after things that aren't necessarily, but I can't apply. Okay,
welcome to the Desert Blockchain
Monthly
Meetup. We're at Gangplank in Chandler, Arizona. We're back with some lettering. See how that goes.
I'm not familiar with that one.
It's 7 p.m. Arizona time, and we're going to be talking about
We'll have to come back to this afterwards.
networks,
But I got a list for you, so.
That's great.
And a variety of topics, the crypto economy, and
Yeah,
this is
over here.
about an hour and a half. And tune in, and if you have any comments, you can go to desertblockchain.com and look at my contact information under the contact tab. So thanks for tuning in, and if you find this interesting. All right.
This is a cool place.
Yeah,
welcome.
it's. I'm gonna go grab some pizza too.
Is there a bathroom?
Yeah.
There is.
Just let me show you right
Cool,
away.
thanks.
And Raphael.
So are we starting this?
We're
Or?
recording this.
Okay, cool.
Sounds good. Yeah.
All right, a little bit of dead air for right now. Cool. Go grab some pizza if you want. We're just fixing up some stuff here.
Yeah, just take the right and then right. No, I got one. Thank you. I got
Oh, oops. Yeah, I've actually found that I'm overwhelming Firefox's ability to handle bookmarks. So
Really?
Yeah,
That's
so
impressive.
I've switched to. It sucks every time I get a bookmark something. It just like hangs for a little bit. It's like this is killing me here. So I've switched to just storing everything in Markdown files because then I can put other text around the bookmarks and word bookmarks. And so I can do a full text search on everything I put in there.
That's what you need,
limited
right?
by keywords and all that. So
All you need. Yeah, I was gonna say if you've got that many bookmarks, keeping track of them, you have to remember and at the bottom to go
finding
back to.
them is difficult. Yeah, it's not fun. So I'm trying to get a handle on that. I'm actually working on a system that falls into this stuff, the category what you guys are looking at. It's been 7 years I put into this and just put in for government funding. So
Really?
if one of the departments bites, we're going to get a whole pile of money to make this thing reality. If not, I got a few other options for making it real. So
Very cool.
yeah.
So why don't we just kind of go around the room and introduce ourselves, and then, you know, if you could say, this is kind of loose in terms of the format and all that, but I'm interested in to find out what you guys know about blockchain, distributed networks, what you'd like to get out of tonight. Sure. And I've got a few things to show you that might be of interest. Go ahead.
Cool. So I'm Raphael, and I actually have never touched blockchain. I've read about it. I have a pretty good friend who's works pretty heavily with it in terms of building like infrastructure for Bitcoin, or I guess the protection layer.
Mm-hmm.
So I've heard a little bit about what he's doing, but and that's as far as it goes. But I would, I guess, love to know more about how it can be utilized. I think it's an amazing technology. I think it's kind of the future, and so I want to be aware of that.
Mm-hmm.
So that's why I'm here.
Cool. And Raphael, do you have a website or something people could go to? I think you are an awesome designer.
Yeah, he does have a great website.
I love your video and all that
Thanks.
work. So
Sure, yeah, it's just raphaelhyde.com, but raphaelhyde.com. Is there like a page I can share it on there if it's easier?
you can just put it on the meetup.
Okay, cool.
Yeah. So,
Cool.
Good.
David Vespoli. I heard about blockchain really through Bitcoin, really only recently, probably 6 months ago. I didn't know anything about it. The concept is certainly intriguing. I'm really interested to learn about different applications outside of Bitcoin or how it might be used in other spaces. The idea of distributed technology in general without a centralized power source is kind of an appealing thing to me. So I'm here to just kind of hear what you guys know and probably soak up a lot, kind of at least up front. So
Cool. And what is it what areas do you usually work in?
I'm mainly a JavaScript developer, UX developer, but I do full stack. I do PHP. I do a little bit of everything. Been writing Java like more than anything lately. So.
You've been writing Java?
Yeah, it's not my wheelhouse, but
It's too bad.
it needed to be done, and so I did it. So actually, it's been fun, but C# a little easier. But
Cool. Ilya?
I don't know if I should try to keep this short or not since I've been a part of a lot of these. And, so anyway, 7 years I've been working on. I've had a fascination with distributed and durable systems, and so I think that was really what caught my eye with the internet. Was back in the old days, like NNTP was actually kind of a cool early distributed system that had no central point of failure, and servers would just kind of sync the sections of the news hierarchy that they wanted. So I've been frustrated to move away and toward heavy centralization and then abusive companies that really, they make their money by screwing their users as hard as they possibly can. And technology moves very quickly. So the law is probably never going to catch up unless we redo the way law is written. So I would like to, for durability's sake, for privacy, et cetera, to really go back to the roots of the internet and look at decentralized systems. And there's some really neat ones out there. A lot of the best research, whether it's decentralized systems or just computing in general, a lot of it is at least several decades old. Some of the best computer science happened back in the 60s and 70s. And we've been screwing around and reinventing crappier, half-assed versions. Actually, half-assed is being quite generous. Most of these systems are a fraction of the original functionality that was running on processors 1/millionth as fast with 1/billionth as much memory, and they had it working great back then. Just it never caught. So my thing is, how do we get this to catch? There's some specific technologies to look at, but just generally, how do we change people's thinking and get them looking at? And maybe this isn't possible, but can we get people to adopt better technologies because they are better, or are we going to be stuck forever in this worse is better thing of just always having crappy technologies because for whatever reason people love crappy technologies? I mean, they do create business opportunities.
right.
If you make a perfect technology, then you can't sell a fix for a problem with that technology because there's no problem. Look at Plan 9 as an example. Great OS is a redo of Unix by a lot of the same guys that wrote Unix. And a lot of screen sharing and all this and remote control with Plan 9 structure, you can do that very trivially. You don't have to write an app. You just mount certain files and boom, screen sharing, done with Plan 9. Everything you need is built into the OS, and it takes a trivial amount of knowledge to cobble it together. And you look at some of the stuff that's been done with VNC and just RDP and all these other screen sharing apps. They all have major drawbacks. They all work pretty poorly. But it's a market, and you have companies like Citrix and others that have built empires on filling in a hole in the product.
Some people feel better when they can write the big check.
Yep.
So
Got to have a neck to choke. So anyway, that's my interest. My project is Nebula. It is a layer 5 project, so it sits on top of stuff like off-system, IPFS, et cetera, which sits on top, hopefully someday, of namedata.net or similar layer 3 technologies. And then if we sit that on top of, at the lowest layer, wireless mesh networking, now we can look at having systems that are truly resilient, durable, and decentralized systems that take a trivial amount of effort to build some stuff that'll be around pretty much indefinitely if someone cares about them. So anyway.
cool.
All right. So my name is Jay Carpenter, and I'm the founder of the Desert Blockchain events, and you can go to desertblockchain.com and follow along. They're almost always recorded on Google Hangout. Alio's contributed a lot to the events, and
I'm gonna go catch up.
yeah, added his expertise. And Alio and I went to an event in San Francisco in early June.
It was awesome.
Yeah,
Thank you for the heads up.
called the Decentralized Web Summit. And on the front page of desertblockchain.com, I've got a couple of links. Well, actually, the videos are embedded there of the 2-day event, and I highly recommend it. It was an amazing gathering of people at the Internet Archive. And if you're not familiar with the Internet Archive, it's a initiative by a fellow named Brewster Kahle that makes a copy of the internet every single day. And it's
attempts to as much as any one company can reach. It does.
And Brewster's in the Internet Hall of Fame, and he and Vince Cerf and Mitchell Baker of Mozilla put this together, and it was just an awesome event. So,
Where do they get the disk space?
well, they got huge archival computers in a church. Like 5 years ago, he bought a church.
That's a good idea.
Yeah,
I was going to attack a church.
And that's a great story. Were you the one? Was it you or Christian that heard that story? So the story, you look at their logo and you're like, oh, cool. Well, they did this logo. It looks very official. It looks like the Library of Alexandria. They probably did that after they got the church. It's the opposite. They made the logo, and he's walking around and he's like, that looks like our logo. And it happened to be up for sale. So they bought the church. The logo existed first.
Wow.
And then they bought the
That's
church.
funny.
Is the logo like a church or something?
Yeah.
Have you been inside the church?
Oh, the whole conference was there.
This is a huge church.
So they have a huge auditorium. They had the conference was 300 people, and there are plenty of empty seats. So they could probably seat at least 500, maybe 6 in there. In so the church, there's just a cavernous upper area. You could do that, and then there's a whole section there's a foyer in the front, and then below that, kind of half level down, is an entire set of rooms in a large area, and just ringed by a whole bunch of rooms where they have kind of offices and classroom space and all this. It's a really
Is it the physical location where they store? Like they've got the sort of like the clean room there, and
I don't know if 100% of the stuff is there, but yeah, a lot of it is stored on site.
What?
And,
Sounds like a movie.
Yeah.
So
So
like
it's
a
very
James
cool.
Bond villain lair.
it's a super hideout, you know.
But
exactly.
Brewster is a very sharp individual, and he realizes that they can never fully achieve their mission with the way technology is now. And so the only way to really preserve humanity's knowledge into the future is to fundamentally re-architect the web, moving back toward the original principles it was built on. And so that's why he convened this conference. There's been a ton of people thinking about these ideas for decades. One of the projects that was there, and that's one of my very few gripes. It was an amazing conference. Some of the newer projects got a lot of press. Some of the older projects got little to no press, which I think was the one thing that annoyed me. Like Freenet project was barely mentioned, and Freenet project has actually been live for 15 years. So it's been around for at least 20, but it's been live actually hosting data in a fully decentralized manner for 15 years now. And it provides a lot of the stuff they were asking for, and it barely got any press. So that, to me, that's one. Tor gets all of the popular press, but Tor is really it's not that impressive. Tor is a redo of AT&T's Crowds concept back in the late 90s. And Freenet, likewise, is a redo of the Publius project. I forget which university that was out of back in also the late 90s. So Publius, they were going to build that. They got kind of scared away by legal concerns and decided not to. Whereas Freenet's like, look, people need this. We're just going to build it. And it doesn't matter what you say. We've already thought this through. They have a wonderful thing on the project page about why they decided to build a normal scaremongering about illicit.
Why the lack of interest? I mean, you think they just don't have the sexy factor? Or
Yes, I think that Freenet is it's not that hard to install, but just hard enough to install that normal people who aren't security researchers or people who are actually trading those type of illicit materials or living under regimes where you need something like Freenet, which is the main reason it was invented. If you're living in countries where even just looking at certain types of data, like things about democracy,
right.
yeah, it'll get you thrown in jail or disappeared, then if you're not one of those people, then you're probably not going to take the trouble to install it. Because it's not that hard, but it's hard enough that it's not just like a click in an app store and then you have it. And it's never going to be that because a lot of the gatekeepers now, they don't want something like that to exist.
Right.
And the other issue with Freenet is Freenet's primary purpose is to provide strong anonymity or optimizes certain network operations. It puts random timeouts, it puts random data padding, so it is not very efficient, and it's even just HTTP stuff over the web.
Sure.
Because if it does that, you get correlation attacks, and you open yourself up to all kinds of things that it's trying to prevent. So between the fact that it's never going to be as performant as the web, and it's just hard enough to install, I think that's my personal opinion. Those are the reasons it never took off, because it has huge advantages in other areas. So anyway.
Okay, cool. So let's, I'm going to do some screen sharing here.
I'm gonna grab another piece actually. Anybody want something?
I'll go out there and see what's left in a minute. Thank you, though.
So let's screen share.
All right.
Okay. So
The obvious thing that Eric is saying is Eric is the senior vice president. The vice president of the teams let go, and then the vice presidents and our directors.
wait till
And then there's
Raphael returns.
so,
Did you get some pizza?
I did not yet. I'm going to go get some in a minute here.
So I'm gonna go, since you guys are kind of new to blockchain and you're interested in what are some of the other applications and stuff like that. This is something that everything else is almost why the big question is why should you care? And in my view, this is another opportunity comparable to the introduction of the internet in the mid-90s. And when you hear the term blockchain, it's really kind of a misnomer. I mean, it's the blockchain is certainly part of it, but it's a much more fundamental paradigm shift,
Right.
than just blockchain. Blockchain sounds like, oh, well, this is the new React, or this is the new Angular JS, or this is the new JavaScript, or something like that. No. This is a really fundamental paradigm shift. So the intention of the events is basically to build community, to provide education and innovation, basically. And the thing that I'd like you to consider is we're all familiar with rewards programs. If we go to Subway, and, they punch your card, and after so many sandwich purchases, you can take that card and you can turn it in for a sandwich.
Right.
And if we fly a certain amount on Southwest Airlines or whatever, you can get a free flight. Well, take that concept and just completely expand it. Because a lot of people say, well, Bitcoin, Ethereum, whatever, there's nothing behind it. Well, what's behind it is agreement and some level of trust. And that's really what money is. It's when we go to Starbucks and we get a free coffee, we trust that at some point in time we can turn that in for a new coffee or a free coffee.
Just like a $20 bill.
Yeah, and it's really no different than if we paid for that coffee. Well, this That's basically the easiest way that I can describe the cryptocurrency realm. And it's in its very early stages, it's global, and it's also introducing something I would say is over-the-top sovereignty. So we all went through the internet introduction with things like voice over IP, which was like over the top the existing structure. This is a whole new paradigm that, in my view, is comparable to over the top voice over IP, over the top Skype, over the top. All
disrupts
that stuff.
all the existing stuff.
It's really disruptive.
Which is why, that's why it's appealing to me. I mean, that's why I think that I like those things, those traditions to be challenged a little bit.
Cool. You hear anything out of that, Raphael?
Right as you're.
So I'm still trying to like. I don't know if I understand. So I guess.
Yeah.
I guess you should know about my background's user experience and design.
Okay.
I'm learning how to program. So I'm about 4 months in.
You're learning how to program?
I want to be a programmer and a designer. That's the goal.
Okay.
How long have you been designing?
5 years.
Okay.
My background's hardware, so I have a mix of like
background for a designer to come from.
Yeah. So
to know hardware. It's like you skipped.
So I love like mechanics and integration of electronics, but now with digital, I felt like there's so much opportunity. But yeah, programming is definitely something I want to become more aware of. So I understand when you say it's like a huge paradigm shift, but I don't understand the complexity and how it interacts with all the other pieces of technology. Probably because I don't know enough about the history.
Okay, so you want me to take that one?
Go ahead.
So blockchain is a subset of a larger concept called the Merkle-DAG. And the Merkle-DAG is a Merkle-directed acyclic graph. And Merkle-DAGs were invented by Ralph Merkle, again, mid-70s, I think 1975 actually. And they were invented as a way, back then, connections were much slower, disks were much smaller. But they were invented as a way, if you have two large things of data, very large pools of data, how do you make sure that this and this are identical? So the naive way is just to go through and just check, is this a 1? Is this a 1? Is this a 0? Is this a 0? But if you have a huge amount of data, that's going to take a very, very long time. And if you have to redo that every time something changes, it's going to be very time consuming, processor intensive. So that's not really going to work.
Just because I want to have a copy?
Let's say you have 2 or 3 servers around the globe and you're trying to keep them in sync. And you're trying to make sure that the data on these servers, let's go back to the old NNTP servers. Let's say you're trying to keep them up to date. Well, figuring out what's up to date, keeping it up to date, figuring out what to move to get everything up to date is going to be very difficult. There's an old program called rsync, and that it kind of borrows from some of that. It uses a rolling checksum window, and if you rsync 2 things together, it will checksum kind of the top level, the lower levels up to the top level. So that's what a Merkle-DAG does. It says every object, you take a cryptographic hashing function. So there's 3 key types of hashing functions. Unless you want to go into those, I'll ignore the other 2. Cryptographic hashing function takes some amount of data. Actually, it could be literally any amount of data. And it does a whole bunch of really fancy math, permutations and shifting things and XORing and all this to ideally create a small fingerprint for that data. And that number has one key property. There's several, but there's one particular property right now that we're interested in called the avalanche effect. So that if you change any one bit, even just a single bit, anywhere in this chunk of data, the entire number is completely different.
So that's an excellent segue into an example
Only the start, but
of
go ahead.
just that. So I'm going to go back to the screen share again, and I'm going to show you something that illustrates that.
Thanks for explaining that.
There's more to it, but I'll let you
only
take it.
imagine.
That's hard.
So one of the things that I'm really excited about is something called IPFS, which is Interplanetary File System. This is, in my view, a very radical new approach. Well, it's not a new approach. It's actually just a combination of old approaches, but it's done in a way that seems to be getting some traction. But this is a very radical way to reinvent, let's say, the entire internet. And what Alia was just talking about, this is a website called example.com. Okay, so this is in a browser, and when I go to, let's see, anyway, I've taken this website and I've put it into IPFS, the Interplanetary File System. And when I do that, this is how you address that same website. So if you look, this is under localhost, and I've got the IPFS running in a daemon. But you'll see that this is producing the same thing as this, only it's not a domain, it's this cryptographic hash. See this long gobbledygook of characters?
Like a calculated vhost entry, or I mean, is it?
I don't know what a vhost entry is.
Or
No.
like,
It's not. So a cryptographic hash, like I was saying, you take some data. Now, the key difference between a Merkle DAG and a cryptographic hash is you take a binary, it takes, like say, a blob, a binary large object, a small one, and you hash that, and you end up with a hash. So the key genius behind the Merkle tree or the Merkle DAG is if you take a whole bunch of blobs and you cryptographically hash all of those,
right?
and then you take the cryptographic hashes of those things and you record those in, say, a directory file, and then you hash that.
Hash of a hash.
That hash, points to
It's
all
like
these.
Inception.
And if anything, anywhere all the way down changes, that avalanche effect goes all the way up the graph. And so
You only have to
IPFS,
monitor that one fingerprint
You
to
only have
know
to look at
about
the
the
top.
whole.
so if
Exactly.
you're comparing two data
That's
stores and you want to see if they're the same, it's a very, very simple string comparison. You look at their top level hashes. If they're the same, you're good. If they aren't, you go down one level and you do a string comparison for all the hashes listed in there. And you see if there's the same number and if any of them are different. Then because the top one was different, one of them must be different. So you look and you find out which one was different, or one. And then if they're that one, again, it's just that one is different, you go down. If it's so you keep going down, and it allows you to traverse this tree and find out where there are differences by just doing very tiny string comparisons.
That's cool.
So this is this. You can see this hash, okay? And then if we go to the,
And vhost, by the way, is just like virtual hosts. Like if you wanted to kind of just make something work off your local machine.
Yeah,
Your local machine
this-
can pretend like anything.
This is totally different than that.
Totally got it. Got it.
So this is the same as this, okay? So the example.com, when you run it through this hashing, it becomes this, it's represented by this hash. But now tell me, what is the difference with this?
The I
The
know.
other one. Yeah.
That's right. But look at this hash. So the only thing that's changed is the L has turned into a 1. But look at how different the hash is.
It's that avalanche effect we were talking about.
Okay?
And the reason we want that is the whole point of a cryptographic hash function is to have a unique signature to identify one thing precisely. And so people are unlike pigeons. Pigeons are very good at doing monotonous tasks for a long time. People suck at them. So if we have a big string of numbers like that and
Like
characters, manually comparing and finding out when one of those is different, people are very bad at that. So by having the avalanche effect, very tiny changes are amplified so that you can compare even just the first few digits of the string,
And you know that it's way
and
off.
you're like, oh, well, it's not the
It's
same
100%.
thing because they're different. So you don't
Or
have to
even
read the
better,
entire
last
string.
few digits.
Either
So you
way,
see
yeah.
this 4 capital MUX
Yeah.
is completely different
Yeah.
than that.
And in this case, the reason the last few digits are better
DIH.
is the QM on the beginning of this. IPFS is they did some really good thinking about how to make it future-proof and forward compatible. And so it does not directly use a hash value. It uses a technology called multi-hash. And so QM is a bit pattern that corresponds to what hashing algorithm this
It's being
is.
used.
So you can see if J flips back
How
and
many
forth.
hashing patterns are there?
There could be an infinite number. Right now, there's only a handful.
So QM points to a particular one. So it
Yeah,
knows
so
how
I
to dehash.
believe that is an SHA-1, or is it an SHA-256?
It's SHA-256.
Okay, so
But that could be changed within.
and that's the
IPFS.
point. So we've seen, even in the relatively short history, the first really popular cryptographic hash function was MD5, or Message Digest 5. And then that was broken. And broken in a cryptographic hashing function, means that you can relatively easily find, by relatively easily, less than brute force, you don't have to do that much work, find what's called a calculated pre-image. So with any hashing function, we're taking a potentially infinite number of values, documents up to any size, and compressing them down into a certain maximum number of signatures.
Right.
So once we go above a certain size, you're going to have collisions. You're going to have more than one document that hashes down to the same value. And that's somewhat of a problem because the whole point is to uniquely identify stuff. So once we can figure out which different things collide in the same hash value,
You need one more character.
easily,
One more
yeah,
character.
that's now considered broken. Because so the whole point is, if I send you a cryptographic hash, I can read it to you over the phone, and you can look at, you can rehash that document and say, oh, it's the same document. If you send him a hash and I look at that hash, but then I can intercept and I can create
What
another
is the
document that
chances that
says
they're the
something else
same?
that I want it to say
Yeah.
that matches, then I can intercept and I can send him, I can throw away your message, put in my message, and you guys will say, does it match? It matches, great. So anyway, so MD5 has been broken. SHA-1 is not fully broken, but it's close enough that most people are uneasy using it for hardcore cryptography. Some of the higher SHA variants, like SHA-256 and 512, have not yet been broken. At some point, there's probably, unless they got lucky and wrote the perfect hashing function, they probably will be. So that's what Juan Bennett, his big thing is, these hashing functions. So far, no one has developed a perfect hashing function that has 0 collisions below its minimum or its maximum unique message length. And therefore, we don't want to be stuck with any one hash function. So we use multi-hash, so we can say, oh, this is an SHA-512, this is an SHA-256, this is whatever the newest thing is as people invent new hashing algorithms.
Isn't it just the problem of maximum possible outcomes, right? So if you, instead of just hash with letters and numbers, if you hash with like full UTF-8, right? Like any character.
It's not treated as an alphanumeric string, but the input is a bit string. It's just bits.
Right.
So that UTF-8 distinction is irrelevant.
I see.
We're looking at just the bits coming in, and it's operating at the bit level. So the encoding is irrelevant.
I see.
But yes.
Well, I just meant that character set, right? Having all those character sets available to you would expand like the possible
So
combinations.
you change-
Even using the same number of characters.
You have any character set
change it
available
back
to you
and spell it with
as the
one
input to the hash function. There's no
same
limitation on
thing.
character set.
Oh.
We're operating on a
So I
bit
can
pattern,
create like a
but then
pages, if I,
instead of
like, code a
making people
page,
type a ton of
then code
ones
it
and
again.
zeros,
I can
we
create
are
the same
compressing
hash.
it down into
Yep.
like a
Really?
Yep.
smaller,
As long as
an
it's
alphanumeric
identical.
character set to
Oh,
represent that. Because
okay.
that is just a bit pattern.
That's a key.
And all of these are interchangeable. You could represent it as an integer, you can represent it as hexadecimal, whatever.
Let's go over that.
Anyway.
I think that's really key.
Go for it. What was the-
Oh, so I was curious if I made a page, if I just wrote a custom page.
Yeah.
And then I deleted it, and then I made it again.
Yeah.
Would it create the same hash for both
If
pages?
you made it exactly the same, yes.
Okay.
And so
And exactly how is that defined? Is that
Well-
bit for bit.
Oh, okay.
Yeah, so if you took that example.com, which anybody can access with any browser,
Mhm.
and you hash the code in that,
Uh-huh.
it will come up with that same hash.
If you use the same hash
Anybody.
function, it will always hash value.
So as long as it's the same code, it's going to come up with the same hash
Okay.
universally, and this is key.
If I don't want that to happen, like maybe I'm getting ahead of myself because I'm thinking like, then if I have a page, oh gosh, actually I don't even understand.
So
the
I think,
question.
I think what you're getting at, let me take it, because I'm pretty sure I get what you're getting at. That's an important insight, so that's great that we have this immutable value that will always be the same, but what if I want to update my page? How do people find it? And so
Yeah, that's a good point.
they have something called IPNS and IPFS that's IP name system that allows you to use a key, a private key, to then say this name, this thing binds to whatever value this is currently pointing to. So I can rebind this pointer to a different immutable value. Now, Freenet handles it a number of different ways. Freenet did stuff that predated IPFS, and they handled the same way, same problem several different ways. And I haven't done a deep enough dive to say whether the Freenet approach was superior to IPFS, but that is an important concept. Like the idea of a mutable pointer for stuff that updates, because like a news site, if you can only go to a static site, it's not very useful.
Yeah.
Whereas a immutable piece of data, you do want immutability. You want stuff, if you're going to archive, like Brewster Kale's talking about, you want that immutable pointer to forever point to that thing. But you want that mutable pointer to point to the new things as it changes over time. So that is a concept that's pretty core to IPFS. Other systems have dealt with that concept, like Freenet Project dealt with it years, decades prior to IPFS. But it's a really important distinction to make. And you even see some programming languages like Haskell make a distinction between mutable and immutable, pure functions and impure, and monads and all that fun stuff. And Haskell's a 30-year-old language. So
is that like a lot of weight for the browser to process if you're pointing constantly and it's having to follow that route?
Depends
like,
on how it is
really.
implemented.
I don't think so.
But yeah, it doesn't have to be.
Well,
So
if you get into IPFS, they've set up a gateway so that there's compatibility with HTTP. And that's, but, you know, there are things even at that.
Gotcha.
Is there a concept of like a constant, immutable kind of way to group, like the concept of a site, right? A site has a bunch of different URLs and different things, but it has a base domain,
So,
right?
just as we talked about, you can build trees. You can build a tree. There's a subset of that. Block, but it's one chain. Anyway, leave that aside for a second. But yes, IPFS supports Merkle trees, where you can have a thing pointing to more things, and each one of those can be, so it can be a whole tree. So that pointer then just points to the top level.
That domain, and then you go from there.
Yeah, so yes, that's something you can do within IPFS.
But the trust that we're talking about here is really key, because basically this hashing gives a huge level of trust that isn't present in today's web. Because how would you possibly know that L had changed into a 1, unless you did some sort of, analysis on the code. To the eye, you just, you wouldn't see it in all likelihood. So,
And is there any additional security over like regular old DNS and kind of, pointing to, because you talked about that being like possibly having some alternative implication where you could use that instead of DNS. You could say, here's the hash, and then you know everything that you need to know without having to go to ICANN. So where's that IP live, and where does that,
There's a whole bunch of
IP,
that's really cool.
IPFS could replace HTTP, could replace DNS, TCP/IP.
Right now it acts as an overlay. Namedata.net would be the thing that would replace TCP.
So
So
let's just put it this way. IPFS is the promise of a radically new net. Okay. So we'll leave it at that.
And that's cool. Well, because if you consider the concept, not that want the world to come to an end or something like that, but under some great kind of event, right?
well,
Right now, the United States kind of sits on all the servers that says where things live,
Yeah.
and a lot of people aren't happy with that. There wasn't the harmony that there is,
and
people
frankly,
would probably want to do.
Well, we
something,
just saw it in real life in Turkey.
right. And see, so then the whole country,
Right.
because the government can kind of just go like, no,
Right.
So-
And the coup attempts started taking over television stations. They want to control the information. We saw it in Egypt. We
because
saw it
it's
in Turkey.
centralized kind of
Yep.
point of power.
Yeah. So anyway,
Cool.
those are some of the dimensions. But let's go back. So do you guys have any questions or comments?
Millions, but I'm going to hold off. I think if there's too many questions, I won't continue down this rabbit hole.
So yeah. Well said. So anyway, that shows a little glimpse into this hashing stuff, and then the Merkle DAGs add yet another element to this whole thing. And part of what I'm really excited about in this realm is the ability to collaborate and bring people together, because we do that with Git.
Yeah.
Git is a way to start to harness and build a community of
It's a proven strategy for sure, right?
of developers.
Seems to be beating out other more traditional things.
So-
Just given them enough time.
Yeah, so let's go back to the blockchain.
Collaboration.
Yeah, and Git's a great example because Git is all Git is, and the reason Git was named Git is British slang for idiot. And Git is the stupid
Is that
content
right?
tracker. Yeah, and that's why it was named that. Is Git is literally a Merkle DAG with a whole bunch of commands on top of this very basic Merkle DAG to let you do some amazing stuff.
Yeah.
But Git's core is a Merkle DAG, and then they do optimizations later with pack files and all kinds of crazy stuff. If you want to go deep into that, there's another meetup group in town called Phoenix Version Control, and they've started doing some more advanced meetups. They kept it pretty basic initially, but the last one was a deep dive into the internals of Git and how that works. And I think
Cool.
several of the upcoming ones are going to be similar. So if you want to learn how Merkle DAGs can be used to power stuff like Git, then that's a great resource.
So in my view, there are three main elements to paradigms, initiatives, and so forth. That's technology, business models, and policy. And those three things dance together. So Elio and I were just talking about Iridium, okay?
The phone company.
The phone constellation of satellites.
Many on that stock like a long time ago.
So there's an example where you have this awesome technology. They had floated this constellation of satellites.
I was like super sure that's everybody's gonna have
Yeah.
an Iridium phone. Like,
Yeah.
And so they had navigated
That
the
was
policy element of how you go beyond all the sovereignties and
yeah.
all that stuff. What fell apart was the business model.
Did the guy die in a helicopter
What-
crash or
what-
something?
No,
No.
what happened was that right when they released that, they needed like 100 people at the rates they were charging, which were quite high.
You'd have to be wealthy.
And
to do it.
Yeah.
right at the same time, traditional cell phones, whatever everyone's using now,
Just
ground
started.
stations plummeted in price. So most people are like, don't actually need to make a call from Antarctic or the
Yeah.
Arctic Circle.
You're too young, but these guys,
So-
they have satellite phones, like
Yeah.
these big satellite phones, and you can basically go anywhere on the planet, and there would be
Well,
enough satellite coverage. You can just make a call from anywhere you
They had a
want to, right?
full constellation of satellites that covered the entire surface of the Earth. And not caves, obviously, but everything else you can make a call from anywhere. And they did orbital routing. So if the call went up in Africa, it would route through the satellites and drop back down in the U.S. Because Global Star still exists, and you can buy cheaper service on them. But Global Star is a satellite relay. So if you make a call in Africa, it goes up to Global Star. If you're in the middle of the Sahara, for instance, bounces down to the nearest ground station and then routes conventionally over ground networks. So Global Star is not as robust.
Slower.
Anyway, so Iridium was amazing technology, but they got beat out by cheap crap. So
The point.
Yeah, and
The
the
point.
guy died in a helicopter crash. I'm pretty sure that there was like some
Well,
scandal
there was
or
a
something.
recent
I don't
Wall
know.
Street Journal
It's still up.
article. It's still up.
if you have a boat and you're
In fact,
traveling in
they're
Arctic
based-
regions, you have to have an Iridium transponder.
Is that right?
The
Okay.
only one that
They
works
still
in
got-
polar regions.
But the
So-
point is
Sorry.
part of this paradigm shift is these three things have collapsed together. So if you think about Bitcoin, it is technology, it is business models, and it's policy, all wrapped into one. It's more tightly, more integral than ever before.
Sure.
And that's another part of the excitement. So what is blockchain? It's distributed, it's trust, it's cryptography, and it's immutable history. Now,
is that a technology limit that people think about? Like, so the limitation on the number of Bitcoins and the fact that you've got this increasing amount of information that you have to perpetually keep?
That was intentionally, well, the increasing amount of information has to do with that it's a blockchain.
Yeah.
And so
you ever just cut it at some point and say,
some nodes can do that, but mining nodes have to keep the whole thing. The thing that makes that somewhat less onerous is Kreider's law. So Moore's law is the one everyone knows, and it's every 18 months the number of transistors on a chip double. Kreider's law is similar from the storage industry, and it's every 18 months or so that the amount of storage you can cram on the storage media goes up by a factor of 10. So it moves much faster than Moore's law. Yeah, that's why Google's never had to throw anything away, because every time they replace a hard drive, it's at least 10 times bigger than the one they're replacing. But yeah, there are some issues with Bitcoin. The deflationary aspect was an intentional design feature they considered. There's some other issues with governance and the trust model that we will see. I'm sure some cryptocurrency inspired by Bitcoin will be around
or
in 50 years.
inflationary? I mean, I guess it depends on what you look at, the way you look at it, the purchasing power or what
it's deflationary, because there's a maximum upper limit on the number of dollars. So once that's mined, then the number of dollars available.
I knew that there was a maximum number of Bitcoin.
6 million or something? It's 21 million Bitcoins is the max that will ever be.
But which has an inflationary effect on the coins themselves, because as more money comes in, the same amount of coins represents an increase of money. So that's why Bitcoin's trading.
Well, because
inflation will work less.
It will rise in value.
Well, that's why I said it depends on which side of it you're looking at.
Let's continue on. The only thing that I'd like to make the point I'd like to make about this slide is that when you talk to people about blockchain or cryptocurrency, it's important to find out how much of that currency do they own. Because
it's awesome.
Excellent.
That's right. Well,
had I only bought, $5,000 worth.
The weaving in the monetary element and all the emotion, money into this really changes people's views. So there are, as this progresses, you'll notice biases. That's all. Now, personally, I own like $20 worth of Bitcoin, and that's it.
Hey, if you bought it at $1, that's
well, actually, somebody gave it to me.
It's $1,200.
And it was worth $8 when they gave it to me. Now it's worth like $22.
Excellent.
Nice.
And I've never touched it. But anyway, and if you've never gotten a cryptocurrency, Bitcoin, Ethereum, whatever, one of the first things I recommend you do is get some.
Buy a little bit.
Well, or find somebody that will give you a little bit. So I want to weave that into these events, because I think holding even a tiny amount of this stuff changes your perspective, and it changes the game. It goes from conceptual to real. So anyway, so here's a few other things. Why is there so much interest? There's interest from governments. There's some interest from central authorities like banks, stock exchanges.
I know you can trade futures on Bitcoin too. I thought that was funny. I saw that.
Yeah, it's so there's all sorts of issues, but there's some really, really fun.
So I'm looking at the 2.1 bullet point, and Bitcoin has proven to be anything but a stable currency.
No. Well, first of all, these slides are a draft, and I haven't fully walked through them with you because for time purposes. But the purpose of governments if you strip it down, is basically to provide a stable currency, provide national defense and police protection, and enforce contracts. If you really, I mean, a view of government is that.
Yeah.
Well, this slide and those three functions are being challenged by this blockchain and cryptocurrency.
Yeah, and it's a problem for them.
So, well, we don't know how it's all going to sort out.
Yeah. I know the futures aren't actually traded on an American exchange; they're traded on Hong Kong, I think, is where they.
Bitcoin futures?
Yeah, I don't think there's anything available as an American currency.
I don't know.
There's also American market.
There's also informal exchanges as
maybe.
well. So, and then central authorities like banks and like the Maricopa County title recorder, all those things are central authorities that provide trust, security, and accountability. Well, those three elements are also being challenged.
Sure.
So the blockchains are pushing these elements, these use cases, and this functionality out to the edge, basically, the peers, all of us.
And they're pushing them out because it's they can provide a more secure network than
it's just an alternative. So with Bitcoin, there is no central authority. The central authority is this set of policies that everybody agrees there can only be 21 million Bitcoins, and how the blockchain works. But there is no like Federal Reserve issuing Bitcoins. There is no Bank of Bitcoin. In fact, this is a big problem because governance is one of the big problems.
And the value instability is probably hard. I mean, if you ever tried to roll that in as a bank or trust and do business in it, you have to basically be on the other side trading futures to try to keep it stable so you're not losing money just because you're holding on to it.
Yeah.
Well, and there are initiatives and companies and startups that are trying to create a
stabilizer kind of. That's cool.
So anyway, I'm going to just kind of flash through these recent developments. The DAO, which actually reversed that immutability. This gets into the policy. In the Ethereum ecosystem, there was a flaw, let's say, in the code, and somebody was able to basically move about 50 million of 150 million into their own account. And the community got together, and it was kind of like a tyranny of the majority. They actually decided to reverse the quote immutable blockchain around Ethereum. And all of that is starting to, we don't really know what the implications of all that will be. So they did the hard fork. I'm going to just kind of skip through this stuff. So this is resources. You can go to books, video, and I'm going to elaborate on this. But the last point is get some cryptocurrency.
So I have a question. Like, how do you, other than get it from somebody else, how do you buy something and get change in it? Or
there are actually Bitcoin ATMs in town.
No kidding?
Yeah.
Really?
Yeah.
That's crazy.
Now, at least one of the people that will be here Saturday has gone to one of these ATMs, and I think there's one in Tempe where you can put in cash and basically get Bitcoins. So that's a way to get Bitcoin.
Interesting.
So
That's neat.
Isn't that wild?
It is.
And in your realm, I mean, if you start to think about what you could do with hardware in this realm, it becomes super exciting. So, anyway, that's about it for this introductory.
Oh, Reddit has a Bitcoin or a blockchain. Is that a blockchain or?
Well, they have blockchain, Bitcoin, Ethereum,
Of course they have
everything. So you can go to Reddit. That's one of the main reasons. One of the main ways that I keep up with what's going on. So anyway,
I have 10 more minutes. I didn't want to interrupt you,
Yeah.
but I hope I don't miss anything. But
no, that's cool. We should probably kind of wrap it up. But
Cool intro though.
do you have any? You guys have any questions or
Yeah.
comments or what?
For me, what's probably a good shallow dive to, or maybe a deep dive, maybe some introductory reading, or even
Good question.
visualization of the blockchain. I mean, I've done a little bit of research. Maybe something you've seen at visualization. I think that's like I learned.
Let me recommend 2 books here. And the Melanie Swan blockchain. Oops. So if you, let's see. So this blockchain blueprint from New Economy is written by Melanie Swan, and it does a good overview that's and other than that. And then the other is Andreas Antonopoulos. And Bitcoin.
Are these pretty quick reads? Are they?
Well, this is more technical.
And my addition would be, I would encourage you to look at broader applications in Merkle bags. Everyone's really, really hot on Bitcoin, and but for other things, using it as a database and other stuff, it's kind of a shitty idea. So modeling general human knowledge works a hell of a lot better in a Merkle bag, unconstrained Merkle bag.
Bitcoin's the tangible thing that kind of like makes you realize that this type of thing exists. Otherwise, just talking about an abstract would be hard to understand.
And that is part of it, is adoption. Everyone's all, and Bitcoin is money. So Bitcoin attracted all the people that want the get rich quick crowd.
Yeah.
And then everyone else, people actually did, some of them got quite rich because they had a few dollars worth of Bitcoin that then exploded several thousand times over, and they made a ton of money. Anytime that happens, you get people's attention real quick.
Sure.
For obvious reasons.
Yeah.
But I think the long-term implications for humanity's knowledge of the Merkle bag is much, much more interesting.
I've got it.
So,
the wiki page, like, go read tonight.
and again, Git is
So-
a good
Start
example
digging.
of what can be done. So.
This is a site that gives you a summary of just under
4 billion.
13. Through the roof. One of the Ethereum blockchain forks that was the sort of like the venture capital Ethereum.
Amazing. Dogecoin.
25 million.
It's kind of a fork on deflationary, faster transaction confirmations, kind of like Litecoin. But yeah, they kind of started it as a joke, and then people ended up actually using it. Now it's I won't say as legitimate as Bitcoin, but it's not that far behind. So, and again, this stuff, those market caps start looking at actual global financial markets that are measured in trillions and above. So yeah, this is a drop.
You got to keep in mind that this is like just the beginning. This is very, very early. So the opportunity for innovation is huge. In my view, this is a paradigm that is just starting to build momentum. When you think about combining money with data, with programming, with the business models, with this kind of like over-the-top policy, I really think this is fundamental. And it's instantly global. So anybody in the world that's got an internet connection, you don't even need an internet connection. Actually, text messaging, you can start to transfer funds and participate in this. And the other part about it, to get back to the Git and the Merkle DAGs and all that stuff, collaborating, coming to consensus. The consensus is achieved among the community, quote, community. When we say community, it's kind of like this kumbaya thing. Right? It's a community that consists of people
in theory
that kill each other.
But they have no choice but to play by the rules, right?
Right.
People that try to get around and cheat
It's take anybody else's resources. Necessarily get along. Everybody and everybody, no matter whether they like each other or hate each other, that is
census database. So I own this would be really so it is an app term. Last I check now. Of carbon. So you're burning electricity, creating and air.
Renewable
Takes that much calculation.
Electricity.
And that gets worse over time.
$600 million.
I'm sure everybody's using.
But there's something called proof of work, which I think is a good way to get this started, but to get off of proof of work and get proof of stake, which is a different way to come to consensus. So
yeah.
Anyway, why don't we? You guys have any questions? You gotta go.
I have to go. I have lots of questions. I think I'll probably read up some more so that I can clear out all the
there's another
basic
event.
questions.
You got slots because there's another event.
You just come for the
Is that
question. I don't know.
on the meetup? So will that have more of a formal? I guess this was pretty formal in the way you
There'll be other people there, and it's going to be a similar format where we'll go through a little bit of presentation things, and then talk, because one of the biggest advantages of us getting together is having this community that has different views and different knowledge sets and opinions.
We've had some excellent lively discurations about some of these issues.
I think that's cool. Yeah.
The one thing I'll ask, I know you gotta go, but
All right.
have you guys?
Good to meet you.
Thanks a lot,
Look
guys.
forward to seeing you on Saturday.
Definitely. Thanks a
Okay,
lot.
let's see you.
Thank you.
See you probably next Wednesday.
Yeah, sooner or later, probably.
Okay, that's what I want to.
Yeah. Thanks.
All right, bye.
Have you guys talked about like any initiatives, like kind of concrete initiatives that because you mentioned like some of the stuff is not getting, Bitcoin gets a lot of notice, and and you got some other projects going.
So
do you have any kind of thoughts about?
They did the decentralized web summit in San Francisco 3 months ago, something like that. We're talking about trying to get the next one hosted here in Arizona, and inviting hopefully all of the same people back, and a few others that didn't make it to the first one. So we want to keep this moving forward. We want to keep this on everyone's mind. I put in for federal funding on my project. My project is, and this is where, Jay comes from a more financial background. My background is more like Brewster Kale. I just want to see humanity's knowledge not get lost because we chose crap technology to base the internet on. So I see the solution to that in some of these not blockchain. I think blockchain for my purpose is a really, really crappy fit. So unconstrained Merkle DAGs to me are the ideal tool to model humanity's knowledge. And even they aren't fully
I
ideal.
totally dig into that. That's a pretty powerful kind of a thing to
Because
say.
one thing that happens is when we model knowledge, I have an idea, Jay has an idea, we might say, oh, those are the same, and we might work together for a while, and then we might change our mind, and we might split back up and form a branch. And Git can model these because it's an unconstrained Merkle DAG. Bitcoin fundamentally cannot. You cannot ever have a branch in a Merkle tree or a blockchain. That's the constraint.
My branch says I have $20 million.
Yeah. So to me, I'm not worried about consensus globally. I actually think the global consensus is not possible and probably not a desirable thing anyway. I mean, name one thing in history that everyone agrees upon.
Well, that's why the great thing is if you can bake the policy into the technology, then you don't really have to get consensus, do you? You just
who gets to write the technology because that's the person who's in control?
Well, if you've written it in a way that enough people can get on board because they
that's
agree that it's
again. But how do you get that group consensus?
Yeah, you only have to get enough, right? You don't have to get everybody to agree, but you get enough people where other people kind of get dragged along with the current. I mean,
so this is an interview with Ralph Merkle. This is an interview with Ralph Merkle that just came out last Monday, a couple of days ago, on he talks a little bit about the Merkle tree and Merkle roots and all that stuff, but more importantly, he talks about governance, and he talks about a new approach to democracy. So, if you're interested in Merkle trees, Merkle DAGs, all that stuff, this is a great opportunity to get it straight from the fellow that originated this. It's at Epicenter Bitcoin, session 141. You can listen to it on SoundCloud or see it on.
So was it Epic Center or
Epicenter?
Epicenter.
EPIC.
Like an earthquake.
ENTER Bitcoin.
So my work again is purely for knowledge transmission, basically giving us what we don't have in today's internet, giving us non-repudiation, giving us provenance data, and preserving, making digital knowledge durable. Because right now it's incredibly fragile. Everyone's aggregating it in one place, and if that place dies, then you lose a tremendous amount of knowledge in one go. So the goals that created ARPANET and later the internet, it was designed as a DoD network to be incredibly survivable. And the phone companies have taken it over, and that old circuit switch thinking has leaked back in. And even though we're pushing packets, it looks way more like telegraph and telephone networks than it was supposed to.
We'll get some satellites out there and be doing it all over that for long.
So that's my work, is to try to move back toward what it should have been, which is a fully distributed and durable network that is highly partition tolerant. So you can have rich communication even if you're in a network or under a network partition. Let's say we go hiking and we want to communicate. It's ridiculous that because we can't both reach a central station, even though we're standing next to each other, our phones are useless. Yeah. That's just really stupid. So, and the amount of bandwidth and electricity and everything else we waste. If I send you a text message right now, it doesn't go from here to there one hop, which I could pass you a note and that would be very efficient.
Your provider's network, and then
it could end up
maybe a satellite.
It could literally end up going on a 1,000+ mile journey to hit different servers. And that's absolutely insane. We're adding a lot of latency, a lot of failure modes, a lot of points that could fail to stop that communication for pretty much zero tangible benefit. So to me, that's a huge problem. That's a massive flaw in the way that our current communication systems are structured. And I find that ridiculous and unacceptable. So I would like a system that, again, highly partition tolerant. If we go hiking, it's the only two of us, the only ones left on the planet. Sure. These still have a charge.
Hey man, they did have the phones with the walkie-talkies for a little while. That was kind of a bypass.
Yeah. So the tech is out there.
So let me go ahead and wrap things up for tonight. Thank you for tuning in, and hope this was interesting. Join us again this Saturday, July the 30th, from 9 a.m. till about 6 p.m. Arizona time. You can go to desertblockchain.com and we'll be live streaming right there on the front of the page. So again, my name is Jay Carpenter. You can contact me under the contact tab at desertblockchain.com. Thanks for tuning in. Appreciate your interest.